Algebra 1, Day 71. So today we're going to be talking about solving quadratics with the quadratic formula. So before we jump into that topic, let's give you a little bit of a history about this. So first thing, what are we talking about when we're talking about solving? Well, what we mean is that we are looking for where this graph touches the x-axis. We're looking for a solution, a root, a zero, an x-intercept, whatever the folks decide to call it. Now, this quadratic formula that we're going to be learning today is something that was a little bit more applicable before people had calculators. And the reason is that sometimes you cannot solve an equation by factoring because it has really crazy roots. They might be crazy decimals or radical or all kind of interesting numbers. And so this formula was a way to be able to work out something by hand or with a minimally functional calculator in order to find the roots of a quadratic equation. Now, this is, like I said, this is a little bit less applicable because now we have calculators that can do this. But this is something that I would like you guys to know and to understand because this may come up in a later math class, okay? So, before we jump into that, I want to talk a little bit more about radicals. So, radicals are going to be anything that's found with this square root symbol, radical symbol. And there's a couple of different things that you need to know. Number one, these can actually be reduced. So, for example, let's say that I said square root of 20. Well, if I type that into my calculator, I'll notice something interesting. So let me go ahead and go here, and I will say square root of 20. And if you notice, it's 4.47214, right? Okay, interesting. So this is almost equal to 4.47 dot. However, we can also reduce this to make it into a smaller form. The way that you do this is you break it down into factors. Now, this is something that once you do it enough, your mind will be able to pull them out. So what you're looking for is perfect squares. So perfect squares are those that whenever we take the counting numbers and we square them, so these guys right here are my perfect squares. So if I can evenly divide whatever number's inside of the radical by one of these, I can take it out and move it outside of the radical and turn it into a traditional number that acts as a coefficient. So basically it goes to the outside and it multiplies. So I'm going to do this the very long way right now just so your mind can adjust to this. So first, whenever I see 20, I say, all right, what factors can I break this down to? Most people would say 2 and 10. All right. Can I break down 2? No. That's the lowest I can go. And I could break down 10 into 2 and 5. So now I have 3 factors, meaning I can go ahead and I can rewrite my radical. Square root of 20 is the same thing as the square root of 2 times 2 times 5. Okay, now I'm going to do this a separate way in a second, but for right now, I just want you to listen to this explanation. So, for those who stay single, they have to stay inside the house. So this 5, he's single. He's got to stay in the house. But for those who have a partner, they get to go out. The 2's went out, the 5 stayed in. Okay? So, the other way for us to think about this is square root of 20 is the same thing as the square root of 4 times 5. I can break these apart And the square root of 4 is positive or negative 2. Same exact answer. Okay? So, that is how you reduce radicals. However, the way that we're using it today is something very interesting called a discriminant. Okay? So, I'm not going to jump into that yet, but what I am going to say is this: square root of a positive number gives me two answers, one negative, one positive. The square root of 0 gives me one answer, 0. However, the square root of a negative number gives me no answers. Now, the reason is that there is nothing that when multiplied by itself, the same exact number, will give you a negative number. Even two negatives multiplied together will give me a positive. And it's when we see these no solutions in this discriminant that we have a quadratic equation that when we graph it, it never touches the x-axis. And if that discriminant is 0, it will touch at 1 point. And if that discriminant is positive, it will touch at 2 points. Just exactly as we said here, when it comes to how many solutions we find whenever the radical has positive numbers, 0 numbers, negative numbers. Okay, so let's go ahead and jump into it. All right, so the third method to solving quadratic equations is using what is referred to as the quadratic formula. In order to use this formula, your quadratic equation must be written in standard form, or also known as this guy. So, this crazy looking formula here is my quadratic equation. This is what it is. And this A, B, and C are referring to these guys up here, A, B, and C. Not really sure why they write them lowercase here and uppercase there, but that's just the way it is. Now, more importantly, this part here is what is referred to as my discriminant. Now, this discriminant will determine how many solutions I have, meaning how many times my graph will touch the x-axis. Okay? So the discriminant is only the part that's inside of the radical. It doesn't include the radical. Okay? So, what does that mean? That means if the discriminant, b squared minus 4ac equals 0, no solution. And if b squared minus 4ac is equal to, not 0, a negative number, also less than 0. So if that discriminant is equal to 0, this will be one solution. Now, why is that? Well, let's imagine that I have a number here, and this turns into 0. Square root of 0 is 0. Anything plus 0, still the same number. Anything minus 0, same exact number. One solution. It doesn't split apart because of this plus and minus, because 0 is unaffected by that. Okay. Finally, if my discriminant is equal to a positive number, we have those two solutions. All right, so let's jump down into it. So first thing, I need to go ahead and identify my A, my B, and my C. Then I'm going to go ahead and I'm going to write out the basic portions of my equation. All right. So now I'm going to go ahead and I'm going to start plugging all of these different items in. So my A, of course, my B, and obviously my C is written in. Now, before I get started on all of this, I want to look at this discriminant because I want to make sure I'm not going through all this drama and going to end up with no solution. So I say 4 squared, that's 16, minus 4 times 1 times 3, 12. So my discriminant will be 16 minus 12, which is 4. That's positive. I should have two solutions. So I'm going to go ahead and start reducing this. And let me just take a moment to clear up a little bit of space here. Okay. It's not cooperating with me here. Alrighty. Well. Alright, there we go. Okay. So, first thing I would do is I'm going to rewrite all of the portions that I've already completed. So that negative 4 is staying the same. 2 times 1 changes to a 2. Let's start handling this discriminant. 4 squared minus 12. I'm going to keep going and I'm going to simplify step by step. Okay. Square root of 4 is going to be plus and minus 2. But they already gave us that in the formula. All right. Now I can go ahead and split this apart. One of them is going to take the plus. One of them is going to take the minus. Now, this means that I should have a 0 located at negative 1 and 1 located at negative 3. Now, these are really easy and simple numbers to help you practice utilizing this equation. However, just know that most of the time when you are using this equation, it's not going to be for this purpose. This is going to be because it is some kind of crazy something that doesn't make sense. So you're usually going to get very ugly numbers, okay? So let us go ahead and drop this equation into the calculator. Let's graph it. So I'm going to go ahead and say this is my example number 1. This is x squared plus 4x plus 3. All right, I'm going to go ahead and do a graph trace so that way I can figure out where in the world all of this information is. So there's negative 1 just like we predicted, and negative 3 just like we predicted, meaning we completed this process correctly. Pretty simple. All right, let's go ahead and take a look at the next one. So here, A is equal to 2, B is equal to negative 3, C is equal to negative 5. So let's go ahead and write out the equation. let's go ahead and fill it in. Notice how I have a double negative. Watch out for that. That's the reason why I write in all of my negatives first. All right, so I'm going to look at this. 9 minus 40. But it becomes positive because of the double negatives. That's more than likely going to give me a positive number, so I'll continue on. Okay, so 3 plus or minus, all divided by 4, square root of 9 plus 40. And I'll keep going. 3 over 4 plus or minus square root of 49. Okay, 7 times 7 is 49. 3 over 4 plus or minus 7. Now I can break it apart. 3 plus 7 over 4. 3 minus 7 over 4. So I should have 1 0 located at 2.5. And I should have another 0 located at -1. Let's verify that with our calculator. So I'm going to go ahead and just open up a new graphing page. This was number 2. And this was 2x to the power of 2 minus 3x minus 5. I'm going to go ahead and run my graph trace. Okay, let's see. This is at -1, just like we predicted. The other one should be at 2.5. And it is. That is 100% correct. We did our math correctly. We solved this problem correctly. Now, again, I want to mention another feature. So if I go to the calculator screen, hit Menu, Algebra, Polynomial Tools, find the roots of a polynomial, leave it as degree 2, leave it as real, I can type in these same numbers and it will actually give me what those roots are as well. -1, 5 over 2. Pretty cool. All right, so let's go ahead and take a look at the very next example. So here we have one that is not equal to 0. So I want to go ahead and get that x squared. I want to get that x squared. And I want to have everything else on the same side with it. So I'll move this 4 over. I'll move my 7x over. And now I'm equal to 0. Once I'm there, I can go ahead and I can then identify my A, my B, and my C. Okay. So, now I can go ahead and plug these in. So now I'm not going to use the color coding, okay? -b plus or minus the square root of b squared minus 4 times a times c. All divided by 2 times a. Now let's go through. First of all, I see a double negative. Make that a positive. I see 2 negatives over here. Make that one a positive. 7 plus or minus, all divided by 18. Put my radical in. 7 times 7, 49. And this is going to be 16 times 9, 144. Okay. Now I'm going to go ahead and continue to combine them. 7 plus or minus, all divided by 18. Square root of, let's see, 193. I have no idea what that is, so let's see if that's even something remotely close to that. No, it is not. It is a decimal. So I'm going to go ahead and break this guy apart. 7 plus square root of 193 over 18. 7 minus square root of 193 over 18. And I'll go ahead and plug these in. 7 plus square root of 193. And I want to make sure this entire thing is divided by 18. Okay. So I got one answer. And let us go ahead and take a look at the second one. So I should have answers at approximately 1.16 and negative 0.383. Let's go ahead and graph this. Or actually, let's use our root finder. So let's go ahead and head home. We're going to go back to my home page. I'm going to hit menu, algebra. I'm going to go find the roots, and let's type in those numbers. 9, negative 7, negative 4. And look at that, the exact same number. So we did this correctly. Again, take a look at these numbers. See how crazy these are? This is going to be usually what this formula was used for, because there's no way that we would have been able to factor for this. All right, let's go ahead and take a look at our very last example. Now, we can totally solve this utilizing the method we just learned. We can also solve it using just radicals. We could divide both sides by 5, take the square root, 1 positive, 1 negative. But let's go ahead and continue forth. I'm going to move this 80 over. Okay. I'm going to say my A is 5, my B is 0, my C is negative 80. So this is going to be plus or minus square root of 0 squared minus 4 times A times C, all divided by 2 times A. Let's start simplifying. 2 negatives make a positive. Okay, this is gone. And here we have 4 times 5, which is 20, times 10, which is 200, times 8, which is 1600. Okay, so this is actually one we can solve by hand without the calculator. So let's do that. So we have one root located at x equals negative 4, the other at x equals 4. Let's verify this in our calculator, and I'll graph this one. And I'll go ahead and run my graph trace. Okay, let's head over here. We have one in negative 4 as well as one on positive 4. So we most certainly got this correct. All right, so I want you guys to go ahead and get started on your example questions, and I will see you next time.